Welcome, my dear students. We are about to begin our second class on error analysis. This is just a continuation of where we left off on the previous class. Before I begin today's class, I'd like to recapitulate the things that we have already covered on the previous class. So in the previous class, the first thing we did is we have defined error. And what was the definition? Error is nothing but the subtraction between true value and measured value. This is what we have learned first. Thereafter, we did some calculations of absolute error, average of individual measurements and all that, and finally we reached to a conclusion that if X average represents the measured value of a quantity to be measured and delta X represents the respective error in its measurement, then the true value of that quantity, which we also call the result, can be expressed by the equation X equal to X average plus minus delta X. Why there is a plus minus? Because we have seen that error can be either positive or negative. Therefore, we put a plus minus sign. So we have seen that if X represents the true value, that is the result of the quantity which we wish to measure, and X average represents the measured value, that is average of all our individual measurements, and delta X represents the error, then the relation between them is X equal to X average plus minus delta X. Thereafter, we have obtained the expression of fractional error or relative error. Fractional or relative error, and this was simply delta X by X, where this delta X represents the error and this X represents the true value. And finally we have written the expression of percentage error, and the expression of percentage error was nothing but fractional error multiplied by 100, that is delta X by X into 100. So this is all what we have done in our previous class. So now let us see our today's class says objectives. What are the things that we shall be covering in this very class itself? That means what are the learning goals? What are the aims of this today's class? Which are the things that we shall be learning in this very class? So we shall be deriving expression of maximum permissible error. Maximum permissible error, fractional error, and percentage error. We shall be deriving expression of maximum permissible error, fractional error and percentage error when the result of a quantity is expressed in the form X equal to A plus B, X equal to AB, X equal to say A by B, X equal to say A to the power M, or X equal to say a to the power m, b to the power n, c to the power l. When the result of my experiment, that is the true value, when it comprises of the form a plus b, or it may be even a minus b, or ab, or a by b, or a to the power m, or a to the power m, b to the power n, c to the power l, then how to get the expression of maximum permissible error, fractional error, percentage error? I shall be explaining each of these terms elaborately. Now, before I go on explaining, I think we have to understand here what is A and B. Here A, B represents the things that we shall be measuring directly. X is a quantity which we may measure directly or indirectly. In a short while, you will understand this point. Here this small m, small n and small l represents integers. C is again a quantity just like A and B. Now what is maximum permissible error? Normally we talk about error delta x. We know it can be positive, it can be negative. But maximum permissible error means maximum amount of error. That is often delta x. So maximum permissible error means maximum amount of error that is permissible, that is allowed. So this is nothing but maximum permissible error. Now let us try to understand what is the meaning of x equal to a plus b. Suppose I give you this box. This is a three-dimensional object. You can see it is just a box of some medicine. I have chosen for ready reference. Suppose this is a box I have given to you, and I ask you, or I put the question to you to give me the sum of this much length and this much length. Say, for example, I consider, say this is the length I am considering. It is my consideration. Say I am considering this is the length. And say this is from here to here, whatever is the length, say I am considering to be b. So on this side it is the length, let it be L, and on this side whatever is the length, let me represent it by B. Fine. And I ask you to give me the sum of L plus B. So you will not directly, you will say put your scale like this, you will measure from here to here whatever is the length, thereafter again you will put scale like this from here to here, and you will ultimately give me the result of L plus B. But you are not straight away measuring length from here to here. It is not that my scale has gone from here to here and continued up to here. No. From here to here, it's my separate observation, capital L, say. And from here to here again, it's my separate observation, it is small b. Now, when I am measuring from this point to this point, when I am calculating the length, by putting the scale like this, as I am measuring, so definitely there will be some amount of error, random error. When I am measuring length from here to here, then again I will have some error. That means I will have error in the measurement of L, and also I will have error when I am measuring the length B. But the answer which I need is neither L nor B, but what I want the answer to be the sum of L plus B. And say I am representing that sum by X. So now you understand what is the meaning of X equal to L plus B. Now if I say the length from this point to this point is not L, I represent by A, then it will nothing but be A plus B. Now you can easily understand, I think, what is the meaning of X equal to A plus B. Now instead of asking you to give me the sum of length of this side and this side, I can ask you, give me the surface area of this particular face. Then it will be what? It will simply be the product of L and B. Now from here to here, as I have said, if I represent the length to be A, then when I am asking that I want the surface area, or rather the area of this particular surface or face, then it will simply be A into B. A into B or L into B. So in that case, my X will be AB. So here you have seen x equal to ab. So therefore it is just a generalized expression that I have written x equal to a plus b. A and b can be anything which I measure. Similar is the case C. Now instead of asking say length or sum of length or area, if I ask you to give me the volume, then it will be, if I represent this is as capital L, then capital L into B into whatever is the height. So in that case the form will be A, B, C. So like that. Suppose, I think you have understood. Now again I am specifically concentrating on x equal to a plus b. X equal to a plus b. Now here you see x equal to a plus b. A represents a length from this side to this point to this point. That means this much is the length A I am representing. This much is the length I am representing by b. And my intention is x equal to a plus b. So the answer which I need is the sum of the length of these two sides. Now I am individually measuring this L. I am individually measuring this length represented by B. So definitely I will have errors in the measurement of this length, that means A or L, and definitely I will have also errors in the measurement of B. Fine. So now let us see the maximum permissible error and fractional error in this case. So x is represented as x equal to a plus b. I think you have understood. Let me keep it here alongside so that you can understand it. So when I am measuring this L or A, let us be specific to A. Suppose from here, this point to this point, the length I am measuring, and I am representing that length to be A. Fine. Now say for example from here to here with my eye, say I am finding it to be 8.6. Say just for example I am finding from this point to this point it is 8.6. So plus minus say 0.1 amount of error. I don't know random error. Similarly, when I measure the length B, say from here to here, it is 6, in between 6.5 and 6.6. So some of you can say it is 6.6. Some of you may say it is 6.5. I don't know. Say it is 6.6 plus minus 0.1. Fine. Now here this 0.1 here refers to the amount of error. So I think I can write the quantity. I can say that A is nothing but this one, B is nothing but this one. So what I mean is that I think I can write the expression of A as A plus minus delta A, and I can write B as B plus minus delta B. The correct answer for B will be B plus minus delta B. The true value, correct means the true value of A will be A plus minus delta A. Then what will be the expression of delta x plus x? Now A is nothing but A plus minus delta A. B is nothing but B plus minus delta B. So definitely x can also be written as x plus minus delta x. So x plus minus delta x will be equal to A plus minus delta A. Now A can be written as A plus minus delta A. B can be written as B plus minus delta B. So x can be written as x plus minus delta x. So x plus minus delta x will be equal to A plus minus delta A plus B plus minus delta B. B plus minus delta B. So I can write this equal to A plus B plus minus delta A plus delta B. Simple mathematics. So now what I find, this is A plus B, and what is the expression of x? This is also as per given condition, because it is, you see here it is given x equal to A plus B. So if I equate both these sides, then I can easily write delta x equal to plus minus delta A plus minus delta B. So this is the expression of maximum permissible error. Maximum permissible error. When x is represented by the form x equal to A plus B. Now what will be the expression of fractional error in this case? It will be delta x by x. Now delta x is what? Delta x is just now we have obtained plus minus delta A plus minus delta B divided by x. X is nothing but A plus B. So I can say that this is the expression of fractional error or percentage error. Fractional error or percentage error. So not percentage. Fractional error or relative error. So what will be the expression of percentage error? This will be entire this quantity multiplied by 100. Delta x by x into 100. So this will give me the expression of percentage error. I hope you have understood it properly. So this is the expression of maximum permissible error. This is the expression of fractional error. This is the expression of percentage error. Now let us concentrate on the form x equal to A into B. If x is of the form x equal to AB, now definitely here A and B are the things which we shall measure. So definitely we will have respective errors in the measurement of A and also in the measurement of B, as we have seen just now while measuring or while obtaining the expression in case of the forms x equal to A plus B. Now if x equal to AB, then what will be? A can be written as A plus minus delta A. B can be written as B plus minus delta B. X can be written as X plus minus delta X, where actually this A, this B, this X represents actually the measured value, and this delta A, delta B, delta X represents the error. Fine. So if this is the case, then X plus minus delta X will be equal to A, which can be written as A plus minus delta A, multiplied by B, and B is what? B plus minus delta B. B plus minus delta B. So now I am multiplying, so it is A into B, so it is AB, plus minus A into delta B, so A into delta B, plus minus delta A into B, plus minus delta A into delta B. Now here this product of delta A and delta B is very very small as compared to rest of the terms, because this AB represents the measured value. Here also I have a quantity A measured value. Here I have B measured value. But delta A and delta B are the errors. These are in general, they are very very small quantities. So as they are the product of very small quantities, so their product will even be smaller. Therefore, for simplicity of calculation, we are neglecting this particular product term delta A into delta B. So now I can write X plus minus delta X equal to AB plus minus A delta B plus minus this B I am writing on this side, B delta A. So if this is the case, then now X, again the expression of X is given as AB. So if I think that this X is AB, then this AB and this AB will get cancelled out. So the expression of delta X will be plus minus A delta B plus minus B delta A. So this is the expression of maximum permissible error. Permissible error. Now let us calculate the expression of fractional or relative error. This is what? Delta x by x. So that means plus minus A delta B plus minus B delta A divided by AB. So it will be what? When I will divide this term by AB, I will have delta B by B. So it is plus minus delta B by B. When I will divide B delta A by AB, I will have B cancel delta A by A. So this is the expression of fractional error. So now I think you can easily write the expression of percentage error. This will be delta x by x into 100. That means delta B by B into 100. Or even I can write plus minus delta A by A plus minus delta B by B into 100. There is no harm in writing this term first and this term second. So this is the expression of percentage error, this is the expression of fractional error, this is the expression of maximum permissible error. Now let us see if x is represented by the form x equal to a to the power m, x equal to a to the power m. Fine, x equal to a to the power m. Now suppose you consider that this is a square. Now it's a rectangle, but for the time being you just consider that it's a square. In that case, if it is a, then this side will also be a instead of b. In that case, what will be the area? L will be equal to a square. So now just as a generalization, we are expressing this L by x and this a as a and this m as 2. So I think you can easily understand what is the meaning of x equal to a to the power m. Suppose I have asked you to give me the area of a square. Suppose it is a square. Then what you will do? You will just measure length of any one side. Either this one or this one. Because it's a square, I am assuming. And after you measure a, you will just square it to give me the final answer. That means the final true value, final result. So final result is represented by x. The thing which you will measure is only a. And after measuring a, you will just make a square. That means this m will become 2. And you will give me the answer. So this is the very meaning of the expression x equal to a to the power m. That means x can also be of the form a to the power m. So now let us see if the form of x is x equal to a to the power m, how to get the expression of maximum permissible error. So if I differentiate this expression with respect to x, what will happen? This will be dx. This is a part of calculus. I hope you have done these simple things in calculus. So if I differentiate it, what I will have? This m will come here, a to the power m minus 1 dA. Now I am replacing this differential operator with del. So delta of x will be m a to the power m minus 1 delta a. So this is the expression of maximum permissible error. Maximum permissible error. Every time it's not good to write full form. So maximum permissible error expression is this one. Now fractional error. or relative error, delta x by x. So it is, I should put a plus minus sign here because this delta a can be plus or minus. So delta x by x will be m a to the power m minus 1 delta a, there will be plus minus divided by x. X is what? A to the power m. So this will be plus minus m, this m I have written here, a to the power m minus 1 divided by a to the power m. So when it will go in the numerator, it will become minus m. So I will be having m minus 1 minus m delta a. That means what? I will have, or rather I will be left off with m delta a by a. So this is the expression of, which is the expression? Delta x by x equals plus minus m delta a by a. This is the expression of fractional error. Fractional error. Then what will be the expression of percentage error? This will be delta x by x into 100. You will understand all these things when we shall be doing few numericals, which are very much essential for your entrance preparation and also for the preparation of your council exam. So this will be equal to plus minus m delta a by a into 100. So this will give you the expression of percentage error. This is the expression of fractional error, and this is the expression of maximum permissible error. Now let us see the case if x is of the form x equal to a by b. Fine. Suppose I have given you this box and say this one is length, this one is breadth, and I have asked you to give me the ratio of length to its breadth. Suppose I have asked you to give me the ratio of length and breadth. That means I want which quantity x, say the result which I obtain I am representing by x, and so what I want, say this is L divided by B. So here this L, if I represent by A, then it will be A by B. So this is the very meaning of x equal to A by B or L by B or anything you represent. So if x equal to A by B is the form, then how to obtain the expression of maximum permissible error, fractional error and percentage error? So this is similar to just what we have done right now. So let us first differentiate x. So it will be what? I can write this x also as x equal to a b to the power minus 1. So d of x will be equal to dA b to the power minus 1 plus it will be a. I am treating, when I have differentiated a, I have treated b to the power minus 1 as constant. When I am differentiating b, I am treating a as constant. So a I have kept it here as constant. So minus 1 comes from this minus b to the power minus 1 into db. So this will be dA by b minus db into a divided by b square, because b to the power minus 1 is b to the power minus 2, that means divided by b square. So I can write, now I am replacing dx by delta x. So delta x will be equal to plus minus delta a by b. Fine. Plus minus here there was minus, now I am representing plus minus because dB can be positive as well as negative. A by B square delta B. So delta X by X, this will be plus minus delta A by B plus minus A by B delta B whole divided by X, and X is A by B. So this will be equal to, first I am treating this term, plus minus remains plus minus delta A by B divided by A by B. So divided by A by B, that means it will be B by A. So first term gone. Second term plus minus, sorry, here I will have B square. I forgot to put this square term here. This will be B square. So A by B square into delta B is already what I have divided by A by B. That means again it will be B by A. So now you can see this BB getting cancelled, this AA getting cancelled, and this B getting cancelled with one of the B here. Here it is B square, it is B. So it will be only B appearing on the denominator. So the final expression which I will be having is plus minus delta A by A plus minus delta B by B. So this is the expression of fractional error. Fractional error. So now you can easily calculate the expression for percentage error. It is nothing but delta A by A plus minus delta B by B multiplied by 100. I don't think I have to write it again and again. So this is the expression of fractional error. Now the last form, and it is a bit long. Suppose X is represented by the form X equal to A to the power M, B to the power N, C to the power L. As of now, we have expressed everything in terms of A and B, as if we are to measure only A and B, and thereafter we are to express the result in terms of A and B. It can be A plus B or AB or A by B or A to the power M, like that. Now we are being thrown to a situation where we are to measure not only A and B, but we are to measure A, B and C. And the final expression is such that X equal to A to the power M, B to the power N, C to the power L. Fine? So in that case, how to find the expression of maximum permissible error, fractional error and percentage error? So it is just similar to what we have done already. So first let us do the differentiation. So dx will be, I am differentiating x, dx will be equal to, when I am differentiating A to the power M, I am treating B to the power N by C to the power L as constant. So it will be M A to the power M minus 1 dA, then B to the power N by C to the power L I am treating as constant. Plus, now say I will be differentiating B to the power N, then I will be keeping A to the power M by C to the power L as constant. This is constant. B to the power N, if I differentiate, it will be N, B to the power N minus 1 into dB. Now I will be differentiating C to the power L, but this is appearing on the denominator. That means I will be differentiating C to the power minus L. So in that case, I have to treat A to the power M and B to the power N as constant. So plus A to the power M, B to the power N treating as constant, and I have to differentiate C to the power minus L. So it will be minus L c to the power minus l minus 1 into dc. So now I am just replacing dx by delta x. So delta x will be equal to m a to the power m minus 1 delta a b to the power n by c to the power l plus a to the power m by c to the power l n b to the power n minus 1 delta b. Now there is a minus. There is a minus. Fine. Okay. For the time being I am putting it minus a to the power m b to the power n c, there is again l into c to the power minus l minus 1. So I can write divided by c to the power l plus 1. Fine. Now what is this delta x here? Delta x is the amount of error, but what we want is maximum amount of error. So when we are computing, when we intend to calculate the maximum amount of error, in that case delta c or this entire expression has also to be evaluated as positive quantity because we want to calculate the maximum. So if we subtract something from delta x, then the ultimate result of delta x will not come out to be maximum. So in order to get the maximum amount of error delta x, this quantity again has to be positive. So as we are calculating, mathematically it is negative, but as we intend to calculate the maximum permissible error, so automatically it becomes a positive quantity. Fine. So this is the expression of maximum permissible error. Maximum permissible error. Now I have to calculate fractional error. So what is fractional error? It is delta x by x. Fine. So say first, that means I have to divide this entire quantity divided by a to the power m, b to the power n divided by c to the power l. I have to divide this entire equation by this one. So let us do it one by one. So let us first divide this term by this. So this will be m a to the power m minus 1 delta a b to the power n by c to the power l whole divided by a to the power m b to the power n c to the power l plus this entire quantity a to the power m by c to the power l n b to the power n minus 1 delta b whole divided by again this term a to the power n b to the power n c to the power l plus this term a to the power m b to the power n l delta c divided by, already it is there, c to the power l plus 1 whole divided by a to the power m b to the power n divided by c to the power l. So it's a big expression. Now let us do one by one. First let us find the answer of this term. So it is m a to the power m minus 1 delta a b to the power n by c to the power l divided by this one. That means it will become c to the power l divided by a to the power m b to the power n. So now this term got cancelled with this one. B to the power n got cancelled with b to the power n. So a to the power m minus 1 divided by a to the power m. So what we are left off with is a to the power m minus 1 delta a divided by a to the power m. So ultimately it will be m delta a by a, and there is a plus minus sign because there is delta a, so there will be a plus minus sign. So this is what we have got from the very first term. Now let us do the second term. It will be a to the power m c to the power l n b to the power n minus 1 delta b divided by this. That means multiplied by c to the power l, a to the power m, b to the power n. So this c to the power will get cancelled with c to the power l, a to the power m will get cancelled with a to the power n. So just here what we have found, a to the power m minus 1 by a to the power m. Here we are finding b to the power n minus 1 divided by b to the power n. So from this term we will be having plus minus n delta b divided by b, because b to the power n, and if I bring this n minus 1 on the denominator, it will be minus n plus 1, so it will be b. So this is what I will get from this term. Now let us see, focus to this term. It will be it will be a to the power m, this is the term which I am writing, b to the power n l delta c divided by c to the power l plus 1, it is already the parent term, divided by x, so multiplied by c to the power l divided by a to the power m b to the power n. So a to the power m b to the power n get cancelled, c to the power l plus 1 c to the power l. So here what we have? It is only c. So we have l delta c by c. So from here what we get? L delta c by c. So you see the expression of delta x by x. So delta x by x comes out to be plus minus m delta by a plus minus n delta b by b plus minus l delta c by c. So I am writing the expression again. From here on you can see the expression. You can see the expression. So I am writing that if x is of the form a to the power m b to the power n by c to the power l, then the expression of fractional error or relative error will be represented by delta x by x, and that will be equal to plus minus m delta a by a plus minus n delta b by b plus minus l delta c by c. So you see, it does not matter whether c appears on the denominator or on the numerator. The form of the expression, this is just the power of a. You see the power of a multiplied by delta a by a plus power of b multiplied by delta b by b plus power of c multiplied by delta c by c. And this is the case for all the forms actually. So this is the expression of fractional error. So what will be the expression of percentage error? Percentage error will be delta x by x into 100. That means it will be plus minus m delta a by a plus minus n delta b by b plus minus l delta c by c into 100. So this is the expression of percentage error, this is the expression of fractional error, and this is the expression of maximum permissible error when x is represented by the form a to the power m b to the power n by c to the power n. So I stop my today's class here. On the next class, we shall be mainly focusing on various types of numericals that usually comes on the entrance examinations based on error analysis. Thank you.